Hi all. In this video, we are going to learn how to create an artificial brain using TensorFlow Sequential model. My name is Manoj Kumar Acharya. I am reachable at this email ID frnd_to_care@hotmail.com. My email ID is given there here. Besides that, I would like to if you can if you like my video, I really liked my video, then please give me a thumbs up. You can also subscribe my channel. I'm planning to upload a few more advanced level of TensorFlow tutorials. And if you want to receive the native notifications as I'm uploading the new videos, then please subscribe my videos. Uh, if you don't have a TensorFlow installed in your machine, uh, you can refer my past video. The video link has been given in the description box. Please refer the link and watch the tutorial. So I have explained how to install TensorFlow in Windows 11, Python 3.10 with GPU support. So feel free to watch my video, uh, uh, and if it's really helping you out, then I would be really very happy. Okay. So here we are going to learn how to use TensorFlow to create a artificial brain. So first of all, let's learn how our brain is functioning. This is our left side image. This is our biological anatomy of our neuron, of our brain. So basically, human brain has more than 81 billion of neurons. So all are connected to each other. As soon as like there are, like you said, those you see those kind of a connector, right? So those are dendrite. So basically the a neuron receives a signal using the dendrite, through dendrite inside the cell. So there is a something that is a red dot, right? So that is called a nucleus. So information used to get processed here. So basically all the information, so like from various dendrites, it used to receive all the informations, and the signal is used to get processed in the nucleus. Then uh, that signal, processed signal, uh, is passed to another neuron through a connector called axon. So this is the how our biological neuron functions. This thing has been replicated in our machine learning, right? So in machine learning, what happens, even we have kind of dendrite kind of structures, basically networks. So a model receives signal through the network, and after that, like, it used to get processed, right? So we have activation functions, or like there might be some other logic we might have a put, right? So it used to get processed there, and once it reaches a certain condition, then that information is passed to the subsequent network, subsequent layer. So this is how it works. So this is at the very high level. So what we are going to do here, we are going to use a dataset called a Fashion Mnist dataset. This dataset is inbuilt in the TensorFlow. So basically what we are going to do, it's a kind of a dataset with labeled dataset. So we have a label like a t-shirt, trouser, pullover, and we have also images. So total dataset size is 70,000, approximately 70,000 images are there, and all are labeled images only. So during the training phase, so we'll be showing an image just like a digital flashcard, right? So we'll be showing an image to the model, and we'll tell the image, okay, so this is the t-shirt. So like that, we'll be giving, we will train the model. So once the model has been trained with a sufficient number of images, then what we can do, we can evaluate the model using our test dataset. So that's it. So let's go to the coding part. Okay, so here I have like opened my command prompt. You might be knowing that iMini virtual directory TensorFlow where TensorFlow has been installed. So let's open the Jupyter notebook. Okay. So let's create a new file. Start from the very beginning. We have to import few namespace. Import TensorFlow as PDF. Let it load. Okay, it has been processed. So now let's see what is the TensorFlow version I have, right? You can see like this. It will underscore version. Okay, so this is the TensorFlow. And besides that, I have also GPU in my machine. So if you want, I mean, whether the TensorFlow has been integrated with the GPU or not, then you can do something like this. Let's say tf dot okay dot list physical devices as the parameter GPU. Okay, so it is saying that GPU device I have already there. One physical device is there, name physical device GPU 0. Okay, so if you have like multiple devices, you will get a list of all the GPU devices, and you can ensure that one by going through the taskbar. So let's go there. If you go to the task manager and performance, you can see here it's showing that I have GPU, right? So one GPU, dedicated GPU, that is NVIDIA GeForce. First GPU that is integrated with the processor, so it is not considering that one. Okay, so this is my dedicated GPU. So you can also check your machine whether your machine has a dedicated GPU or not. Okay. Now let's see. So what we can do, let's load the dataset, Fashion Mnist dataset. So what we can do, tf dot garage dot datasets. Okay, let's see what's there. Fashion Mnist dataset is there. Okay, so what we can do, we can let's store it in a variable. Mnist. Okay. Okay. Now we have to load the dataset, right? Mnist load data. Basically, we have to load the dataset. Yes. So here, we can directly load the data. Whenever we're loading the data, it is used to give us in a X10 X-test format, right? So what you can do, you can check the documentation. To go to the documentation, just keep your cursor here on the load data and press shift tab. Okay, and then expand it. So you can see this is showing the classes, right, that we have in the Mnist dataset, and this is showing that the returns. So whenever we load the dataset, it returns in a numpy array, which is a format is like this. So I'll say copy it. Let's open a notepad. Okay, and also copy this classes, right, for reference purpose. So right, okay. 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 So let's copy and paste it here. Okay, so this is what we did. Just copy paste here. Okay, we are done. Okay, so one convention we used to follow. So X should be in a capital letter and Y should be in the small letter. Let's edit it. It's a simple the convention I am following. Okay, now load it. Yeah. So this has been successfully executed. So now what we can do, we can check the size of the each numpy array, right? So what we can do, print if okay x print check okay, so shape, let's see it's working. Okay, so we can check the shape of the remaining also, how they are coming up. Okay, something got wrong, I think it's like that. Train, my train, X test, X test, Y test, Y test. Let's execute. Okay, so extern has its, let's say 60,000 images, and similar level is also 60,000 levels are there, corresponding levels, and X test has like 10,000 images with it. Y test is the 10,000 levels. Okay, so that's the fine. Now what we can do, we can check like how the data set looks like, right? So what we can do, we can plot it. So let's go back here. Let's import and plot leaf dot pyplot HPLT. Okay, then what you can say, let's separate it here, PLT and dot PLT dot figure, basically PLT dot figure. Okay, and then PLT dot IM show. Okay, so basically what we are going to show, we'll see the external image, right? So just we're testing, right? Extend 0, and we can use a color code also, that is the CMap equal to gray. Okay, so let's print it. This looks like an ankle boat, right? So you can see like what is the white trend it's saying, right? What is the level for it? White trend 0. Okay, so 9. So basically it's showing 9. So 9 is the ankle boot, right? So what we can do, just let's keep this class pasted here for our convenience. Okay, mark this is cell type BG markdown. Okay, so this is the classes we have. Okay, right. Now what we can do, we can see, okay, let's test one thing, like in our white trend, okay, so how many unique values are there, right? It is showing that it's like a 0 to 9. So what we can do, we can check the unique value ourselves also, like a NP. Okay, so that's also in a NumPy. So what we can do, import NumPy as NP. So here NP dot unique, right? And inside it, let's pass the entire array. Let's say white. Okay, so we have like a label, like let's say 0 to 9. So it says the 0 to 9. So then we confirm, right? So whatever it's showing, it's there. So all the levels are existing in the white red. So if I like a no data is missing in the white red, so I mean we have taken a good training set. It's a good sample basically. Now what we are going to do, well, will be I'll create a model. Okay, so in the like a sequential models, right? So we are going to build a sequential model, and this is a classification problem. It's a basically a multi-class problem. It's there are like different type of a classes, right? One is like a Boolean class, right? It has only yes and no, yes, no. In my next video, I'll be coming up. I'll be cover up like how to create a model for a like a binary classification. And but this is a like a multi-class classification. So TensorFlow, what it used to do, basically we have to create 10 outputs. There will be 10 tensors output. That will be the final layer. So basically, whenever we'll be showing an image, right? So each layer, each tensor will try to find out, detect. So what this image is. Let's say one tensor is which is meant for the t-shirt, right? So it can say, okay, so I'm guessing it's a t-shirt, but my guess is just like a 5%. Second one, a tensor might be saying that, okay, I'm guessing it's a trouser, but my guess is it's a, like a, it's matching 10%. Features are matching. So like that, each tensor will be giving, will do a guess, and which tensor, like which would be like giving it the maximum probability, maximum percentage of a probability. Let's say it is saying that okay, so tensor meant for the 9, right? It is saying that it's an ankle boot. Basically it's a 9, and mine is like, let's say 80%. My guess is 80%. So the brain will decide that, okay, then we can say this is an ankle boot, right? So this is how it works. So basically you might have like a hard story, right? So if an elephant like let's say three blind persons are going and like they're thinking like, okay, how that elephant looks like. So one person touched its leg. Then he's saying that, okay, the elephant is just like a pillar, long pillar. And another touched its tail. So he's saying that no, it's just like an elephant is just like a rope, right? So basically there are certain features are matching with certain things, and their guess is some kind of a probability, right? And if like a person with an eye which is like looking at the elephant, right, then what he can do, like he can match all the features, and then he can tell that, okay, this is not an pillar, this is not an rope, this is an elephant. Okay, so similar, same way the TensorFlow is working in the same logic. So whichever tensor is giving the best bet, then the model predict that, okay, so this, I mean this is this item image is an image of a particular that item. Okay, so now we'll create a we are going to build the model. Okay, so for that reason, first of all, we have to create a tensor we are going to having a very simple TensorFlow. It won't be like a multi-layer. It will only have one layer. So we are going to create a TensorFlow which is like 10 neurons. It's starting from the 0 to 9, so it will have a 10 neurons. Okay, so let's do that one. So what we can do, let's say white train dot max. Okay, so it's giving 9, but we want like 10 neurons, so because it's starting from the 0, so that's why it's the 9. It's actually it is 10. So we can say number of classes. Okay, so that's all. Okay, so that's the like that number of tensors we are going to create. Now we'll create a model. Okay, it is going to be a sequential model. So what we can do is tf dot keras dot sorry tf dot keras. Okay, so first of all, okay, layers, then one minute, tf dot keras. Okay, just a minute. Sorry, tf dot keras. Sequential. Okay, we got it. Sequential. So let's go the documentation again. How it is there. Okay, we can create a tf keras. Okay, then what we can do, we can add a dense layer basically, and there is also another way. Tf keras sequential. This is also another way. Okay, so there are different ways of doing. It's like adding a layer like that. So what we can do, we can do everything while the declaring the more class itself. So what we can do, okay, inside tf dot keras dot layers dot flatten. Okay, so what we can pass here, input shape, input shape. Okay, equal to, so we saw that here it's a 28 by 28, right? 28 by 28, so we'll be passing that one, input shape equal to 28 by 28. 28 by 28. Next, what we can do, add a comment. So we'll be adding a one dense layer only. So tf keras dense. Okay, and in that, so we'll be adding the number of classes. Okay, so that's all. We are not going to add any other things. We are not going to add any activation function because the thing is we have only one layer, so we have only one dense layer. Okay, and we have we have flattened the array of 28 and 28. Okay, so let's execute it. Okay, done. So what we can do, we can do a summary check. Summary. Okay. Okay. Uh, okay, so we'll go to the next one. That is a okay. So yeah, so I was just checking like okay, so let's execute it. The Okay, so we can see one for pattern one, but we don't see anything for the dance. Okay, okay, I got it. Square bracket should be here. Basically, everything should to be inside the square bracket. Okay, so now, yeah. So basically now the dance layer is saying that it has created 7,850 dance layers, right? So uh, let's calculate. So how it's getting this number, right? So what we can do, we have input step is like 28 and 28, right? 28 into 28, okay. And beside that, we have 10 classes, okay. So again, you can say, okay. So basically, it's coming around 7,840. So what are the rest 10, right? So rest 10 is nothing. That's the bias. Basically, the model has added 10 bias into that. So that's it. It's coming in the 7,850. Okay, that's fine. Nothing to do with it. So we have created the model. Now what we'll do? We'll compile the model, right? We have to compile the model. So what we can do? Model compile. Okay. So in the compile, so what the parameters we are going to pass, right? So same way, just go to the documentation, right? It is taking an optimizer, then a loss function and a matrix, right? Besides that, other things are also there, but we are not going to take all the things. So what will be taking only the optimizer, loss and the matrix. So those three things we are going to take. Okay. Optimizer for tf.keras Adam. Okay. Learning rate is 130 plus 2 square bracket. This is for the matrix. So what we can do then, can copy it. Okay, so what we'll do, we'll compile the model. So let's go through the documentation part. So basically we need an optimizer, we need the loss and another is the matrix. So that's all we need. Let's go there. Okay. So optimizer is Adams. And loss function is basically we want a sparse categorical cross entropy. So what you can do, tf dot is there in the keras losses there, categorical sorry, sparse categorical basically we need. first categorical cross entropy. Okay, so this one we need. And here we have to pass one parameter, that is from log its true, and our matrix is just accuracy. Okay, so that's the thing. Okay, so let's execute it. See, okay, it's successfully got executed. So just to like understand like what is the ADAM, right? So this is an optimizer. So optimizer is nothing but the learning rate, right? So when the model starts learning in the training data set, so what it will do, there are different ways. It can go with here long steps, and it can go with small steps also. So if it is taking the long steps, then there is a possibility of overshooting the minimal. So I'm just taking an example. Okay, so this is a graph. I'm just trying to demonstrate. So basically, this is, let's say this is your all the data points. This is the graph has been plotted using all the data points, right? So if you're going with the big steps, so let me take this one. If you're going with, let's say, big steps like this, right? Then there might be a possibility of crossing this minima, right? So if you're going on the small steps, then it will take a long time to reach here. So that's why. So ADAM is basically what it will do. It will start with the big steps, and once it is it realize that it is going towards the like a minimal, so it will be reduce the step size. It will become small and small. Okay, so that is the optimizer ADAM used to do. Second one is like from logits. Basically, what we are going to like what the data set normalization is required, right? In the TensorFlow, normally the data set must be normalized. If there are like many features are there, and there are like big numbers and small numbers, right? So it needs to be normalized. Then it will work perfectly. So since we have the data set only 0 and 1, we don't need to normalize. So that's why we are passing this functional from logits to true. If you need to normalization, then we have to pass it false. Okay. And then the matrix that we are relying on, that is on the accuracy. Okay. So okay. So now what we'll do? Now we'll fit the model. Okay. Model fit equal to model dot fit. Okay, then we'll pass all the again like you can go for the documentation, right? So what it's doing, we have to pass the x value, y value, right? And then how many epochs we need to run, and then validation data also we can provide. Validation data also we can provide. So that's what we are going to do here. So x value is our x train, right? Okay, y value is y train. Second is like how many epochs we are going to run, right? Epochs equal to, let's say, 5, and verbose equal to true. Can say verbose equal to true. Basically, it will show what is happening while the model is running. And then we can say validation data, right? So that is, check the validation data, verbose. Okay, validation data is our basically we're passing the x test and the y test, right? X test, then y test. Okay, so that's all. Let's execute it. See. Okay, so our accuracy is increasing in each epoch, it is increasing. Okay, so now our accuracy is at the 80%. Okay, so our model is done. Now what we can do, we can do a forecasting, right? We can do a forecasting. So for that, what we need to do, model dot predict. Okay, so let's predict for the X test, right? So one is a X test, let's say 0. Okay. Okay. So it is showing that input layer is 28, training close, mask. Okay. Accession interval calling layer sequential, input layer dense, incompatible with the layer. Okay. So basically what it is, they're saying that the array that we are providing, right? So it is not correct. So what we can do, we can provide in this format. Same thing. Okay. So it is saying that it is giving on like each neuron, right? Each neuron they are predicting something. So first 0th neuron, it is giving an accuracy is -94. Second neuron is saying that -322, -9, 121, 58. So something they are predicting. Okay. So what we can do, like we can check, I mean, which one is the best prediction. So for that, what we can do, NP. Okay, let's store it in a variable. Let's say bread 0 equal to this. Okay, so now get a p dot arguments, right? And insert that, pass something like this, bread 0. Let's give me the 9. So basically it is saying that the first image is 9. So 9 is nothing but the ankle boot, right? So what we can do, let's plot it and we can check. Okay, so what other things, other way we can confirm, like we can have the y test also. Y test 0, basically 9, right? So it's confirming with that one. So that's all. I hope you might have liked my video. If you liked my video, then please give me a thumbs up. And if you want to see my latest videos that I'm uploading in future, then please subscribe my channel. And you might also give your comment in the comment sections. Thank you for watching this video. Bye.